Welcome back, everyone. So we've had quite a journey going from studying the solar system to exoplanets to now thinking about life. And we're in a position now to ask the question, and perhaps even think about the answer to the question that we began this week with, which was, are we alone? Is there life, intelligent life, anywhere else in the universe? So that's what we're going to spend the next few minutes thinking about. Now, that last term in the, or last couple terms in the Drake equation really are in some sense about evolution and also sociology, right? So one is, how rare is intelligent life? What's the fraction of planets that develop life that actually go on to form intelligence? And then the other one has to do with the fraction of a star's lifetime that there's a civilization. And so that's really about the average lifetime of a civilization. And that, you can phrase as how long do we last? How long till we kill ourselves? So let's take the first problem, which is intelligence. If you look at the history of the Earth, what we find is that the Earth formed about 4.5 billion years ago. DNA and self-replicating molecules, there's already bacteria by, 3.5 billion years ago. Single-celled animals are there by about 2 billion years ago. That's those single-celled animals have actually changed the atmosphere. It's actually by those single-celled animals farting out into the atmosphere that they completely changed. They added oxygen. There would be no oxygen in the atmosphere if it wasn't for the respiration of those organisms. And so around 2 billion years ago, we see oxygen-rich atmosphere forming. And because of that, a new kind of bacteria evolved called the eukaryotes with a nucleus, which was actually much more efficient for creating more complex life. And so that led to multicellular organisms around 600 million years ago. And then, Homo sapiens with their intelligence show up 100,000 years ago, right? So there's a whole lot of time there before you get intelligence. And remember in the last lecture, we talked about the idea that life forms pretty quickly after the planet does. But intelligent life doesn't form until quite a ways after. And in fact, the Earth is kind of at the end of its habitability. The planet will not be habitable, most likely, because of the increases in the sun's temperature for more than another billion or so years. So we're really kind of at the end of the planet's habitability, and life is just, or intelligent life is just appearing now. So if you just take that piece of information, you'd think that, well, intelligence may not be selected for very easily. Intelligence is not something that appears easily or readily in the evolutionary record. Now, that's all we're doing is just inferring from our own history, from the Earth's history, but that's all we have right now to understand. Maybe perhaps intelligence, is occurring all over the place in other civilizations, and maybe once intelligence occurs, that it's so effective for evolution that everything else, nothing else matters in some sense. You see the domination that we've had over our planet over the last 10,000 years since civilization began certainly points to the fact that we are a remarkably adaptable species. Our intelligence allows us to be remarkably adaptable. So these are the sort of questions that we have to ask when it comes to thinking about whether or not intelligence is the fraction of planets that create life, or that develop life, that actually go on to evolving intelligence. And we can also think of how many times has intelligence actually formed on this planet, and it seems, at least the kind of intelligence that creates technology, it seems only once, unless there's some piece of the record that we're really missing, which would be pretty much impossible. We're the only species that has ever developed this kind of technological energy harvesting kind of technology. So that then leads us to the question of how long does a species that generates energy harvesting, energy intensive technology, how long will it last? Because this is really the essential question for our own species, right? So we have had maybe, the Industrial Revolution was about 200 years ago. That's when we really started really gaining, really multiplying per person how much energy each human being had access to. And, what we've seen is by around, 60 years or so ago, we developed atomic weapons, which certainly could wipe out civilization. And now we're at a point where we're seeing that just, the unintentional consequences of building this global energy-intensive civilization is pushing the Earth into new climate regimes, such that certainly the Earth is going to be fine, but it may make civilization, the project of civilization, very, very difficult. So whether or not we survive with, 7 billion or 10 billion of us on the planet and our remarkably, interwoven, networked global culture with its technology, whether that can make it for another 50, 100, 200 years, that certainly is an open question. So that leads us to the question of what is the average lifetime for a species. Now, we certainly would like to believe that it's tens of thousands, hundreds of thousands, millions of years, and we'd all like to believe that. But part of this question is going to really be wrapped up with how the ability for a species to identify the problems that rise as it becomes a global, planetary scale, and the inevitable consequences of using that much energy. You can't use as much energy as we're using now without having it feed back on the planet that you inhabit. So that's one thing I think that really has come out of our understanding of the last 20, 30, 60 years. So that's something that any species that evolves is going to have to deal with. So what we're left with is we can look at the Drake equation and we can put in the things that we know and we can put in the things that we don't know. And the answer of our question very much determines is based on some of those terms we don't know about, like how long a species lasts. So this is why it's so important to explore other planets and moons for signs of life, because that's going to tell us something about at least the terms that have to do with the evolution of life. And then, try and get a better understanding of at least our own fate, our own possibilities to see things like the understanding the number of, or the length, the average lifetime. Now, depending on what you put in for those terms, like the fraction of planets that have life, the fraction of planets that develops intelligence, and the lifetime, the average lifetime, the galaxy is either teeming with civilizations or where there's one in, a billion, and so there's only a few more of us, or, 100 of us. Or it could be even worse than that. People tend to sort of think like, oh, there's so many stars, of course the universe, there's life, intelligent life in the universe. But think of the possibility, what if what if the odds of forming an intelligent species were 1 in 100 trillion? Right? If that were true, then you could go through every star in the galaxy and you'd never find another one that had intelligent technological species in it other than us. So you'd essentially run out of stars. So if intelligence is very rare, then that means that the universe is not teeming with life. And there may be there may be some other examples, but not so much that we'd ever meet anyone like us before. So there is this thing called SETI, Search for Extraterrestrial Intelligence, that is actually looking for radio signals, looking for intelligent radio signals. Then hopefully that, that would be, hopefully, if that were to, if we were to find any evidence like that, that would be the most astonishing discovery in the history of humanity. So up to now, they haven't found anything, but of course they haven't been looking very long, and the universe is very big, and the radio dial is, there's a lot of different frequencies you could look for. And also it assumes that some alien species is sending messages in radio. Perhaps there's some other technology we don't know about, Z-waves or something that they're using. So the remarkable conclusion that we're at now is that we have evolved to the point that we can look to the stars and we can understand where we are, we can understand how we got here, and we can ask the question in a scientific way about how likely or unlikely it is that we will ever find anyone else. And that probability has to now be measured against data taking. And we are all living in an age when some of that data has already come to us in the form of understanding, the discovery of exoplanet systems, as we've been describing. And probably over the next 20, 30, 40 years, we may discover bacterial life on one of the planets in our own solar systems. We may discover signatures of life on other planets. So really, this is the most exciting time you could possibly imagine for this field.